Bhai, thank you very much for the introduction and giving me this opportunity to make a presentation on something I have started about 8 months ago, and I believe it is very useful. Food gets spoiled and has a typically trashed because of growth of fungus, over ripening some produce, sprouting of tubers, wilting, losing waters, and overproduction that often causes a lot of spoilage of food and waste. To preserve food or to minimize the food waste, a variety of materials and processes are used to preserve the food that include drying, including freeze drying, canning, and also deep freezing at minus 40 degrees centigrade, which can extend the shelf life extensively. And also by adding preservatives, variety of preservatives are allowed. So refrigeration is another one. Once we buy the food, home, we at home we refrigerate it. Often it is ready, food is radiated, especially in the United States, and also wax coating is widely used in the developed country as well. Only about a quarter of the food produced in the world for human consumption every year, approximately $2.5 trillion worth of food either get wasted or lost. That $2.5 trillion almost equivalent to Indian economy. And here are those percentage of which food group and how many percent get wasted. That is according to FAO. So 20% of the meat and grains and all that, quite many, but total comes to $2.5 trillion worth of food is wasted. And in India and developing country, it is usually higher. It's said about 40%. And still 11% of the population is either undernourished or go hungry. So we have developed some method to extend the shelf life of food. So I'm giving you some representative examples of novel material methods and devices developed at JP Labs for extending shelf life of food. And all data I'm presenting here, they are all conducted at room temperature, which is about 25 degrees centigrade. I'm describing them. How did we do this? How did we treat the food? So one way we do it, we call pre-exposure method. It means we take a container. Here we shown with a pot, a glass container, take with a petri dish inside with a paper, and that paper is then this container is loaded with the food, and then in the petri dish, and this paper is weighted with about 0.1 to 0.2 shelf life. Shelf life extender is closed. Somebody's volume is on. Container is closed and is taken out at a predetermined time. And now we have selected this pre-exposure method because it can be really applied in the field by small farmers, where they can have a box, and it can be closed. So box can be closed. Air gas. We use liquid, and liquid can be pulled through, and a vapor can pass through the container and come out, and which can be either scrubbed or recirculated. The other method we use is called controlled release sachet method or sachet method, where we take container in food in a container, and then a sachet is it's a plastic film containing, and then there is a liquid inside. Slowly that liquid diffuses out and creates an atmosphere of the food, atmosphere of which extend the shelf life. So this is the second method which we are using. First one is, as I mentioned to you, pre-exposure. Second one is continuous exposure. So if you have sachet, it can continuously provide the environment of the shelf life extender. Often it is called modified atmosphere. And this is also practical for farmers to use it, because they can put the food in a container, and then they have a lid with the sachet. Sachet can be anywhere in the container, and then they close it. Now this can be stored and shipped for a long time. The third method and fourth method are very simple, just soaking or washing. So we take beaker, for example, in our lab, we take the solution of the shelf life extender in a beaker, add food in it, or produce in it, and then we close, and after a predetermined time, we remove it, wash it, dry it, and then store in a container. And the fourth and last method, which is also simple, just to add, if it food is liquid, we add a drop of this liquid shelf life extender. By the way, that drop I added is a chemical we eat every day, and I labeled that chemical as chemical A, but that is the food, that is a food component, and we eat in microgram every day. So all the samples, this is the way there would be typically, we write the date we started and sample number 1, 2, 3. Sample number 1 is then the control. By the way, as I mentioned to you, the chemical I added in the milk was the one we eat every day. At this stage, I'm not disclosing the name because I don't want anybody to misuse it. So criteria we use for determination of spoilage, at that time, at this stage, we have not used any analytical method. But the criteria we use for determination of spoilage, one is the fungus. If fungus grows, we discard it, and that's a second one is the change in the state. If liquid becomes solid or curdling, then that's the second one. Third one is color change. It produces changes from green to yellow to red. Other one is over ripening, means softening or becomes soggy. Bad odor and the wilting. So, and then also sprouting, if it is germination or something. These are the criteria we use for determination of spoilage. Now the presentation, I'm going to first describe how I'm making this presentation. Slides are presented this way. On the top of the slide is always the samples, control samples. Here in case of the tomato. And then this is so on the top is a control sample. At a different time, there could be sometime 2 or 3. Here we have one more. Then we also, at the bottom portion, I show the samples which were treated with some chemical, either pre-exposure method or other method, sachet method, dipping or so, and then at a different time. And here you can see this tomato control sample ripen in 9 days, while the sample which was, or the sample which was treated took, even after 9 days, it is still green, and it took 18 days, almost twice as long it took to ripen it. And also once it is ripened, it lasts almost twice as much. So when it is C, I'm using it, we have coded chemical number C, A, B, C, and also, and P means a pre-exposure method, is just for my information. So you can see shelf life is quite a bit extended by this method with the chemical C. And you can see after, I often would show the video. So listen, it's still very fresh. Can't remove the stem. See how fresh it is.
Very fresh.
So we can delay the ripening, and once it is ripened, the shelf life of the ripened food is also, or produce, is doubled. Now, when it is liquid food, as I mentioned to you, we add, and here I'm showing you with the milk. Milk is the control sample started.
Navsari.
Then after third or fourth day, it started curdling, became solid. And the one you can see after 2 weeks, and this is third week, it still remained where I added that one drop. You saw the video, which is a food component. We call compound A only 0.1%. And after 21 days, it still remained fluidy, still liquid. Even after 28 days, it was still liquid. No bad odor, no curdling. This is the sample number 1 control sample. You can see after 4 days, it curdled. While you see after 21 days, the milk is still fresh. It remained fresh, no bad odor, no precipitation. Even after 3 weeks, just like almost as fresh as, no anything we could not detect visually or by smell wise. Even after 28 days, you can see it is still very fresh. And this is all was stored at a room temperature, 25 degrees centigrade. So shelf life of milk and liquid products can be extended extensively. even can be stored at a room temperature. And we believe this is so-called cold chemical sterilization. Otherwise, it is not possible, and we have reason to believe it. And if at the end, if time permits, I would show it. So we tested more than 10 such compounds, though we eat one, but there are 10 similar compounds which also work equally well. Now the milk, India is the largest producer of milk next to United States, which produces half of it. And about 20% of the milk and the dairy milk products are wasted. So that is lost to the world is about $200 million worth of milk and dairy products are wasted globally every year. That's a sick to date for to store is the pasteurization and refrigeration. There are a large number of materials and processes are proposed in the literature. Only one which is approved is this one by FAO is lactoperoxidase, thiocyanate, hydrogen peroxide. Liquid foods, not only it extends the shelf life of milk, but also we tested about 15 different juices, fresh fruit juices. Here is that of tomato and control sample. You can see in 3 days fungus started. After 5 days, it became significantly more fungus. And while the one where we added 1 drop of that food component, it even after 20 days, there was no bad odor, no fungus. Actually, it lasted 35 days before we discarded it. As you can see the top portion here, you can see the fungus, and here there was no fungus. So shelf life is significantly extended. So we've been able to extend shelf life of about 15 cold pressed fresh juices. Now meat and fish, I'm a vegetarian, so we did not do extensive work on this one, but we have tested, meat, fish, and chicken. So here is an example. It's not extensive study like others. We have repeated no less than 3-4 times to check the reproducibility and optimize the system. While in case of this one, we have not. As you can see, meat, if first day is almost fresh, but second day it went bad, while the one we treated with is still relatively fresh. We have also tested chicken and fish. Now the berries and fungus. There are large number of fungicides are proposed in the literature. There are quite many, matter of fact, this is big long list of it. So we have something so special that it is a liquid and we expose to vapor. So this is the control of the strawberry. You can see on second day fungus started, and in 5 days lot of fungus, and it also started leaking. While that one which was treated, you can see it remain even after 5 days, berry is still pretty fresh. Now the blueberry. Blueberry on the second day at room temperature, it started, you can see the fungus growing. After 5 days, lot of fungus, while the blueberry which was treated, and you can see there is no, even after 67 days, there is no fungus. Watch the video next, even after 67 days of storage, virtually 2.5 months of storage at room temperature. These were the raw peanuts, the fresh raw peanuts, not the dried one. As you can see, after 13 days, the fungus started growing, and after 24 days, you can see a lot of fungus. While they're stored at for 1 month, 1+ more month, there was no fungus. Now processed food, those were the natural fresh food. Processed food, cake. You can see control sample which was not treated. Fungus started in 6 days, and in 8 days fungus started growing, while the one which was treated pre-exposed, no, this is sachet method, and then that you did not develop fungus. Then another processed food is we took puri. Puri, in about 5 days fungus started, and you can see in 15 days lot of fungus grew. Well, that one you can see one which was pre-exposed. That pre-exposed even after 70 days, a month and virtually 2.5 months, and still it remained fresh. And see the video next. Even after 2.5 months, still it is as fresh as day one. Still soft.
Same as other.
Same thing with this roti, chapati or rotli. In 8 days, it grows faster because it's not fried. So in 8 days, fungus grew. While even after 80 days, the roti remained as good as literally as good as day one. You can see I'm opening it. So there's no fungus. It still did not dry out or did not do no color change or anything.
Still soft. Complete.
Same thing with the rotlo, but millet bread, it goes, fungus grows faster, but even after 70 days, it still remained as good, literally as good as day one. Then among the other processed food, cheese. You can see in 7 days, fungus grew in the control sample, and 9 days, lot of fungus, while the which was treated with the sachet method, it's still up even after 10 days, no color change, nothing, is still fresh, no bad odor. Now the thickener, for tomato ketchup and all that, lot of in the food, lot of thickeners are used. So one of most widely used thickener is guar gum, and we forgot to take photos, but after actually started fungus growing, started growing in about 2 to 3 days, and in 12 days it was whole thing was lot of fungus. While the one which is even after 90 days, there is no fungus. So and this whole thing started when 5.5 years ago we were using another thickener for another application, and that when we even after 5.5 years when we took this photo, is still no fungus. So we have very good control over fungus for variety of foods. Now the grains and the germination. There is problem when unseasonal rain causes havoc in India for the farmers and even warehouses, not even down there. Here also flooding caused a lot of problems. So here is one example where rice. So rice was first soaked overnight, then water was drained and then stored in a closed container. So this is the start, and you can see in 5 days it became soggy and it started stinking, very bad odor. While you can see the one we had added that food additive by sachet method, you can see that even after 21 days, there is no bad odor or nothing. And watch the video, even after 21 days, it is literally as good as day one. So it's a wet because that's where we started.
Wet, no smell.
Then the wheat. You can see wheat, within 4 days they started germinating. Here is shown the photo of enlarged portion. Well, that even after 21 days, there was no germination, no bad odor, no fungus. And you can see the video here after 21 days. It's slightly swollen, but otherwise no harm done.
Not bad, very little smell.
And then that was just wet, but when even if they remain soaked, when we add that chemical, in that, which is also a food component, even after 34 days, there is no germination, no fungus, nothing, no bad odor. Germination of the legumes, same thing it applies. We use mixed legumes, and you can see in 4 days, it started germinating, and 6 days, lot of big germination. While that one with the sachet method and chemical A, after 21 days, still there was no germination whatsoever. And you can see the video here. After 21 days, it had smell of legumes, but otherwise it remained ungerminated, no fungus.
Smell, but it has good one.
So, and mixed legume in flooded with water or soaked in water, even after 17 days, there was no fungus, no bad odor other than typical odor of legumes. Sprouting of unhusked and unshelled grains and nuts. First, I'm going to show you with the rice that this is unhusked rice and that they were soaked overnight and then put it in this container. And you can see, I mean, in a jar, in 5 days, they started germinating. 8 days, that big germination. While you can see the one which was treated, even after 60 days, still no germination, no fungus, nothing. So you can see this is the video of it after 60 days.
No bad odor. Copy. Very hard, still very hard, no soft.
It looks like there was no effect of water. And then we left it in the water, so flooded with water.
No bad odor at all.
Even after 30 days in water, no germination.
Still very hard.
The shell did not become soft or anything, it retained its hardness. Now is the unshelled peanuts. You can see in the control sample, in 2 days it started germinating and it became quite big, a big sprout in 8 days. These peanuts were soaked overnight and then drained and then stored in the jar. You can see in the control sample germination, but in the treated sample, even after 18 days, there was no fungus, no germination. So sprouting of the tubers. Potatoes, we had done earlier, we recently started with the smaller where we can, so this was under 100% relative humidity. There is a jar inside with the water, so the humidity can be maintained, not water, but just humidity can be maintained. So as you can see, control sample in about 5-6 days, it started sprouting, while it took 15 days, it started growing bigger. While that with sachet method, you can see there is even after 15 days, there is no germination. Same thing with the onions. Onions, the control sample that black fungus started growing in 8 days, and a lot of big fungus, even one onion started even really bad. And this is again a relative 100% humidity. And you can see this, while that was treated even after 15 days, and no fungus, no germination. And this is even better because, today that compound called CIPC, chlorprophan, which is now banned in Europe, even manufacturing is not done in Europe, this fogging, so there is a need for a substitute. Obviously, there are a large number of candidates still, they are being tested and used currently. Actually, there are a large number of these being proposed for prevent sprouting. So delayed now the ripening of the fruits and vegetables. Tomatoes, I've already shown you that we doubled the shelf life, delayed the ripening. At the same time, a ripened tomato remained fresh for almost twice as long. This is the mango control sample. Here it takes longer time to ripen because of cold. We store at 25 degrees centigrade compared to hot weather in India. So in here, you can see there is no ripening. So we can delay the ripening of the mangoes as well. Now the tindola, you can see in 4 days, tindola started turning yellow, and in 6 days they turned red, and also fungus grew. Here you can see the sample which were treated by pre-exposure method. So they remain fresh. They lost slight color, but still see how fresh they are, or crunchy they are. It has lost light color, but otherwise it is fine. Then next one is parval. Same thing, you can see in 6 days, parval started turning yellow and fungus started growing on it. Well, that was which was treated, no fungus, no turning color, still remained fresh. And then guar in 6 days, you can see fungus started. While that one was treated treated with by pre-exposure method, even after 17 days, no fungus and still remain fresh and crunchy. You can see in the video. Slight loss of color, but otherwise no harm done. And then there are a variety of materials being reported in the literature, and one of the most widely used or studied is this called 1-MCP, 1-methylcyclopentene. That compound works very well, matter of fact, but it is almost 100 times more, 100 to 1,000 times more expensive than the chemical we use. So then vegetables, flowery vegetable, broccoli and cauliflower. So you can see broccoli in 3 days started going bad, and in 6 days it turned yellow. While the one which was pre-treated, you can see it takes much a longer time to turn yellow. Leafy vegetables, we tested number of them, and we had a problem with the controlling time because they are so sensitive and require so little exposure that we had a hard time to control it. Same thing with the leafy vegetables, coriander, methi, and all kind of the leafy vegetables. We need to expose only for a few minutes or extremely low concentration. So here we took parsley, which is the kind of coriander, Mexican coriander. You can see in 7 days it started turning yellow and then became mushy. While the one which was treated, you can see it remained green and no mushy. But this control, it requires real good control. If you overdo it, does the damage, and if you underdo it, doesn't work very well because they are very thin. Now, that is just some examples what work need to be done. Extensive work need to be done. Above were some representative example. I only showed you 1/3 of it. But in the past 8 months since we started that project, because of lack of time, it is not possible for me to show all the results. Extensive work is under progress. We're still doing very extensive work. However, I want to emphasize that what we have done is just demonstrated feasibility of the concept. We have not tested by any analytical method or how safe it is or any adverse effect. We have not done such a testing. So extensive analytical work is required to be done to determine any chemical, biological, or nutritive changes, as well as to understand the mechanism, which enzyme and how it delays and how it affects, and if treated food is safe to eat. All those 2 studies are still required. This project is gigantic. If you can think of it, we have touched almost every kind of food, fresh produce, meat, and liquid foods, and all kind of produce, leafy, and it is very big, gigantic project, and requires collaboration with university. We are working with here as well with the universities and companies. And it requires good collaboration because you people have expertise on this one, while I lack both expertise and instrumentation. And however, it's going to take pretty long time, but we have demonstrated that this really works. Only these 2 need to be determined. So main objective, you can see when I started the project, it was not really well-defined objective, but this objective, you can see using this simple means, instead of large equipment and complex processes used currently, with the small which small farmers of developing countries along with large farmers and processor and distributor can use. These materials, methods and equipment, they can be used from small farmers to large farmers. Using a small number of chemicals, we have not used more than 4, and still we are touching everywhere. So instead of hundreds of chemicals was used today, I showed you some examples. There are hundreds of such fungicides and biocides, shelf-life extenders and everything. And we use, one of them is naturally occurring, while the others have very low toxicity. These I'm very acutely aware that material has to be either food component or extremely low toxicity, and also should have very low price, very affordable. Utilizing material method that can be applied to a vast variety of foods produced, be it liquid, semi-solid. We also have tested a lot of sauces and processed food. You saw roti and cheeses and all that. So far you can see have positive and beneficial impact on agriculture and food industry as well as the society. The impact, I believe this is a humongous project for me. And if materials used have no adverse effect, and that is the key word, if there is no adverse effect of the few materials which we are using, which I doubt would be, because this is the food we eat, or the chemical we eat literally every day. So I doubt it would be that bad effect, but need to be tested. So if there is no adverse effect, then it have potentially a huge impact in very many ways. It affects the agriculture and food industry and every one of us every day, because we eat every day. Its monetary impact would be enormous as well, significant saving to country, world, whole world, farmers, consumers, people. And it also creates new businesses with a huge international market. It affects our health because we are adding we're using only few chemicals, so it can be very well studied rather than hundreds of them. And export, when you are exporting food abroad, then it can last longer by sachet method. Military can have a little fresher food. Universities, and this is what I believe that we have pioneering work. Nobody has done this before, so anything you do, that would be, your paper would be the first, and it can have very high citation index. And it's very pioneering original work. I would like to acknowledge that large number of people been helping me from very long time. Dr. Jivra Sutaria, a good friend of mine, Ramesh Bhai at your university, he's a good friend of mine and helping me for years. My nephew, then Sudhir Dave, he's a really great help. Then Jasmine, your Kenny, and there all the 2-3 Padma Shri people are also helping me. Muni Mehta, Dr. Sivaram, and all vice chancellor. Whenever I come, I visit to agriculture universities. I have been to all 4 universities twice, and I also have got good support from our vice chancellor, Professor Dr. Kulkarni, and I'm also associated with Patanjali, and many people here also help me. And this whole project I wanted to start but could not start till these 2 people. I'm really grateful to these 2 friends, good friends and alumni of SPU, Harshad Patel and CG Patel, requested me, to start this project and extend shelf-life of produce by wax coating in May 2020. We started with the wax coating and we went into completely off direction, but that's good, And so I wanted to start, but this last push came from these 2 gentlemen. So I'm really grateful to them for pushing me into it. And I have one young person helping me. This lady been helping me for 11, 12 years. And she's very hardworking, dedicated. She's so well organized. That is Miss Julia Colida. And we would not have achieved, certainly not without, in such a diverse field and unknown field to us. So I thank all these people. Now is a question, anybody has any question, I would be happy to answer.